In this example, we are going to be finding the equation of a tangent and a normal to a curve given a specific value of x where that tangent and normal make contact with the curve. Just before we get started in actually solving the question posed to us in this example, we want to do a little bit of visualization to help us see where we're going and what we're actually calculating. What you see here is a plotting of the curve y equals 2x squared plus 8 over x squared minus 9. It makes this odd shape symmetrical about the y-axis, kind of like two skew-looking parabola type shapes. Interesting curve to have a look at, but this is the shape it makes. And what we're interested in is that if we were to imagine the tangent of this curve, the gradient of this tangent will change, become either less steep, flat, or negative, depending on the value of x. As we slide the tangential point along the curve, we see that naturally the gradient of this curve will change. The question is asking us that when x is equal to 2, what will the gradient of this tangent be? And the second part of the question is saying that also if we had a normal formed where x is equal to 2, the normal being a line perpendicular to the tangent that passes through the same point of contact as the tangent, what will the equation of that straight line be? Okay, so to summarize, our goal is, given the curve y equals 2x squared plus 8 over x squared minus 9, what is the equation of the tangent to this curve at the point where x equals 2, and also what is the equation of the normal to this curve at the point where x equals 2. That is what we will be working out algebraically in our example. The first thing we want to do is we are going to have to differentiate this curve. We're going to have to find an expression for the gradient function. To help us do that easily, we're going to convert it to make sure that it is written in a way that makes it easy to differentiate using the power rule. And that means removing the x squared term from a denominator and writing it as an x to a power of negative 2. This allows us to differentiate it easily using the power rule. So a differentiated expression will become 4x minus 16. That negative 2 times the 8 to make negative 16. And then the negative 2 drops down by 1 to become negative 3. The minus 9 is a constant term. Constant terms do not affect the gradient of a function given any particular value of x. So the negative 9 can just fall away. It is always advisable to write your answers with positive exponents on all your variables. So we will write this differentiated expression as 4x minus 16 over x to the power of positive 3. Right, now that we have an expression for the gradient function, we need to find out what is the gradient at the point where x equals 2. So we can now say that when x is equal to 2, the gradient of y will be 4 times 2 minus 16 over 2 squared. What we have done is we have taken this value of x equals 2 and we have substituted it into our gradient function to find out the value of the gradient when x equals 2. When we simplify this expression, we will get the value of 6. So that means in this equation here, in this function here, when x is equal to 2, our gradient will be equal to 6. Something else that will be useful and necessary for us to know is we will also want to know what is the y-coordinate in our original function when x is equal to 2. So for that, we will substitute the value of 2 back into our original function. And when we do that, we get the value of 1. Okay, so we find that when x is equal to 2, we get the gradient of 6, and the point of contact of the tangent to the curve will be at the point 2, 1. We're going to use that point later on. Okay, now we have all the information necessary to find the equation of a tangent and the normal at this point when x equals 2. Let's start off with the equation of the tangent. Okay, now we know the gradient of the tangent and we have the coordinates it passes through. So we can simply use the technique of finding the equation of a straight line given a point it passes through and its gradient. And we find that when we expand and simplify this out, we get y is equal to 6x minus 11. So that minus 1 was just, we added 1 to both sides. That's why we see it as a plus 1 on the other side. Okay, hopefully we are all good with that. To find the equation of the normal, we're going to do a very similar thing, but now except that the gradient of the normal will not be the same as the gradient of the tangent. The gradient of the normal is going to be the negative reciprocal of the gradient of the tangent. Because the gradient of the tangent is 6, the gradient of the normal will be negative, the opposite sign, and the reciprocal 1 over the value of the gradient. From here on, we can use a similar technique. We can just say y minus 1 is equal to negative 1 over 6, open bracket, x minus 2. And once this has all been simplified out, we should get a final answer that y is equal to negative 1 over 6x plus 4/3. And there we have the equation of the normal.